I am fresh back from paternity leave. Well, I guess sort of back. I'm very, very tired, so I'm not going to be on camera today. But today we want to talk about some interesting topics around build versus buy, which is a problem that I've had to solve many times in my career. On the webinar, I have three amazing individuals. I've got Ashan, who is a member of our newly minted data engineering practice, doing amazing work. I've got Burv, a distinguished engineer who has done work with us for many years and done lots of amazing things across various platforms and companies. And then I've got Paul Scarsis, who is our engineering director, who runs several of our sports and entertainment companies alongside some healthcare work and some hospitality work. So thanks, gentlemen, for joining us. Pleasure to have you guys. How we're going to run this is we just want to have a panel discussion on the build versus buy with respect to our platforms. So first, I want to do some definitional work here so that we're all on the same page. So number one, let's define what a platform is. A platform, from the perspective of any company, is the software or the series of pipelines and softwares and data that you use to solve a business problem. This can be anything from the platform that is your data lake to the platform that is your CI/CD system to the platform that is your application lifecycle management, all the way out to your SaaS product that is what you use to produce business value and to get paid for. As you have all likely encountered the question, when do you build versus when do you buy? This is a very subjective question, and it's very dependent on what you're trying to do, and very dependent on what your systems that you have in place. So the first question that I want to put out there is when any company says in your respective lane, again, each of you having a different perspective on this, when a company says that we need a more modernized platform, what do you hear, and what do you think about when you're discussing developing and planning architecture for a modern air quote platform? And again, state the domain you're coming from before you answer the question, just so we have a nice clean line on what you're thinking. How about we start with Jeremy Bervin, the distinguished engineer? What do you think?
Yeah, distinguished engineer coming from the engineering background. To me, that tells me that there's either an applicate. Let's say that they're upgrading something, right? If they're upgrading something, there's
Mhm.
typically either an application running on a Windows form or some old school application that's just legacy code, and they want to make it, whether it's a dynamic browser-based system or some
Mhm.
other upgraded version. They want, React front ends and service-based backends and scalable APIs, things like that.
Mhm.
That to me, whether it's, just the UI or the scalability from the infrastructure point, that is what modernization means to me, typically.
For sure. What about you, as Sean, from a data perspective? When you hear we need a more modern platform, what are some of the things that you think about?
Yeah, so from a data engineering perspective, I would say that the first thing that comes to mind would be cloud versus on-prem,
Mm,
depending on scalability of the product.
hmm
But I think another like main specifically data engineering thing is medallion architecture,
hmm
because it's really important to be able to separate data into different layers. And if there is an error at the raw level versus if there's an error, say at silver, which is right before the aggregations. You don't have to replay from the ingestion itself. You can start from bronze itself. Every single layer, bronze, silver, gold, has a certain gate of quality of data. And
hmm
modernization is important in that sense because that could save a lot of time and resources from that replayability standpoint, as well as when you get to the metric and report level, being able to have standard definitions of different terms instead of having um, everything just computed in like one script.
For sure. I think medallion architecture was an obvious extension of sort of the older school Kimball style models that I remember, probably 10 years ago that I worked in. And I really like that architecture. So I think a lot of existing companies are going through replatforming their data into a medallion architecture. As a matter of fact, I think the client you're working for is kind of doing that as well. They're replatforming into more modern tooling, into a modern medallion architecture away from something that's just all the data that we have shoved into some giant lake. What do you think about Paul? What do you think about this question?
Yeah, it's a great question. I my first thing that I think about is honestly, it to me that means that the current platform, whatever they're on, just feels old. Like because if they're coming to you and saying we need a modern platform, that means that whatever we have right now just feels dated. And then from there, that's when I want to start digging in and asking them questions in terms of, okay, well, why does it feel dated? A lot of times this could be feature problems. The old system that we have just doesn't have the features that we need. We've scaled our business, we've grown in business. We need new tools, right? It could also just be it, like Berg said, it was built in old architecture. It's non-responsive. It just feels clunky. Uh, it looks like an old application. It doesn't look like a slick new web app. And it just needs to feel more responsive. It needs to feel faster. We need to stop dealing with all of these legacy errors and slow screens that time out on your web browser and clunky user flows that require you to jump through a million steps to do what you actually need to do. So for me, this is a question that prompts more questions, or a statement that prompts more questions, because I need a modern platform that could mean a million different things to a CEO. So
Yeah, for sure. And I think you hit the nail on the head in that all three of these perspectives are important when you're considering how how do you solve the business problems that are in front of you. And again, we've all worked in legacy code. I remember one of my first projects was a VB script for this company, and it was a similar challenge where the stakeholder was not super excited and happy with the data flows and how the data was architected. The ETL jobs were Windows tasks on a task scheduler on a desktop on literally in someone's cube. So there wasn't any unified Alteryx flows or any Airflow DAGs. It was literally Windows scheduled tasks on top of UIs that were built in Windows form. So I feel like that entire project was an exercise in when should you modernize versus when shouldn't you? And for this particular system, we made the decision to not modernize it. We made the decision to hand that off to an existing engineering team and then use the resources on the engineering side to redesign and replatform into the modern cloud architectures that they had, some of the concepts that were revenue generating in this particular platform. But the only way we could figure that out is by going through these ideas and looking at the software and understanding what business value is it providing? What can we use the data for? How can we monetize this data and turn it into something useful for the rest of the business, which there was a lot there? And how do we re-architect and re-platform this inside a cloud platform? And again, getting that estimate and making the decision, you know what, we're just not going to do this. So the question is sometimes the answer is not let's pay all this money to rebuild everything. Sometimes the answer is let's just sunset this thing, take the ideas that we got from it and translate them into a more modern position, which could either be through purchasing an existing platform that solves these problems, like God help you, Informatica. Sorry, I hate it, but it does the job it needs to, or something, or rebuilding this in a Lambda in Amazon Glue. Like there are plenty of ways to think that through and to solve that problem. Cool. So let's talk about the next question. Let's see. How about so as far as like when you're thinking about replatforming, when does data engineering and software engineering, where do you two meet? Let's sort of start with the perspective of the software engineer in the room. Let's go with you, Bert.
Yeah, I think too often as software engineers, we just don't think about data engineering that early in a project life cycle. I think we can think about it a lot sooner than we typically do. Most engineers and when I say most engineers, I'm talking about, lower level SWEs are thinking through how do I get this application to do what I want it to do, and not necessarily how do I get the application to do what I want it to do and store the data in a way that is future proofed. And by future proofed, meaning analytics based, which is where that data engineering comes into play. A lot of engineers will just say, I need a table. That table will satisfy this. I'm now done, right? They don't take it one step further and think, how is this data going to be used in other? Um, so I think we could do better at that.
Yeah, I think there's a lot of overlap. I'm a software engineer too, so Sean, you'll have a really great perspective on this and help inform me even. I think of it in terms of I think software engineers should be fairly dangerous at data modeling. You should understand the basics of indexes and how to optimize your OLTP. But when it comes to warehousing design, I feel like that's where software engineers don't necessarily need to care about the intricacies of how a medallion model is stood up. But the data, the raw data, has to be in a position to where the data engineers can use it to get what they need. So, Sean, what's your perspective on that? When do you pick up a set of tables that have been built by software engineers, and how do you think about turning them into business value from a data engineering perspective?
Yeah, so I think each business they have their own line, but I would say, as you said, when you have say an application being used, anything that's related to like the actual factor transaction, like OLTP related, we can have software engineers keep track of that. But once you get into transformations, once you get into an analytical database, once you're trying to build reports for data analysts, data scientists, that's when the data engineers should take over for essentially all the transformations, the cleaning the nulls, and all those things. I would say, ideally, in an ideal world, software engineers would just call in a an API endpoint, which for if there's any kind of calculations that need to be displayed for a certain application, the data engineers would be able to just take care of that. They wouldn't need to do any other complex aggregations, transformations, deduplications in the ideal world.
Cool. And Paul, how do you see this sort of coming together again with you sitting across both of those disciplines? How do you see the interactions and how do you see that sort of coming together to, so the band's all playing in the same key, so to speak?
Yeah, it's a good question. I think a big part of it is getting the folks together to actually discuss what we're looking to accomplish, what we're looking to do, what is the data that we're creating, how are we looking to use it. To Burb's point, I think a lot of times in software engineering, there's a tendency to just kind of throw that stone over the wall, throw that ball over the wall of like, okay, I've done my part of the I've done my part of the situation and now I'm done with it. Okay, I've created the data that we need and I'll throw it over. The data engineering team will handle it now, right? And then data engineering team is dealing with all this garbage and dedupes and having to do a lot of extra work on their end that probably could have been avoided had they been a part of the initial conversations when we were talking about what data do we actually need? What insights are we actually looking to gain from this? So I think I don't know exactly where that line is, but I think the key is to make sure that everybody is involved in it earlier than later. I think one of the things you don't want to do is punt that down the road and do everything that you can on one side and the other, and then try to mash those two systems together. They really ought to be built side by side with one another so that there's a core understanding between the two different teams.
Yeah, and speaking of collaboration, Sean, what do you see when it comes to what are some of the things that software engineers do that you wish perhaps they had done differently when it comes to thinking about stewarding the OLTP data and how that eventually makes its way to you? What are some common best practices that you would encourage people to adopt?
And wait, so just if I understand this correctly, this is at which point of the development cycle?
Yeah, so when engineers are building, so the typical life cycle, right, is that I get a ticket to go and build a particular feature on an application, and a lot of modern stacks, I don't have a DBA team that I phone and say, can you please design this entity set for me? Can you build this relational data set for me and deploy this particular SQL out into production? And a lot of the teams that we work with and the teams that I've worked with, where the engineering team are developing and building those data models. So, and it's easy to say that the engineers, at least I fully admit as a software engineer, I don't always think about all of the idiosyncrasies of downstream data, especially when it comes to warehousing. The power of something like the medallion model is you don't necessarily care too much because you've got the raw granular data and you can transform that into anything interesting so long as you have all of the data points. But I'm wondering, are there any particular sort of problems and challenges that you've seen that maybe on the software engineering side, we could spend more time thinking about a better model? And the answer may be no for this, but just thinking it through, I'm sure there's something that I can do better before I hand you my data model.
Right, right. And again, I think to be quite honest, like I with the work that I've done as a data engineer, a lot of it has been pretty separated out from software engineering.
Gotcha.
But back to what everyone says, I think having meetings to understand the data model, having both data engineering and software engineering align with the exact business use cases, and perhaps having a
Mm-hmm.
data model that does not require complicated joins for
Mm-hmm.
something that could just be like stored in maybe one table. So I think, as I know this sounds very generic, but the best way to do it is just have the data engineers be understanding exactly what exactly is going on in the software engineering
Mm-hmm.
development cycle, but also have the software engineers be like understand potential data models and what exactly data engineering plans to do with the data downstream, so that data analysts, data
Mm-hmm.
scientists can make value of it.
I do think that's actually a really great point, in that I'm certainly guilty of using junction tables for everything in many to many relationships. So it makes perfect sense to maybe sometimes it could just be a little bit simpler. Um, so what do you see, Paul? Again, going back to this collaboration conversation, what have you seen with respect to? Are there any challenges between these two different disciplines? And what are some things that you've seen that might improve collaboration between the two?
Yeah, I think one of the biggest challenges is just getting the teams to stop thinking of themselves as completely separate entities, right? I see this happen. It's honestly, it's not just the platform team and the data engineering team. A lot of times this is even broken up to like the front end team, the API team, the back end team, the data engineering team. And instead of everybody looking together and saying, hey, we're all responsible for our product and we're all responsible for our app and what we deliver, everybody thinks of themselves as no, 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 no. I'm only responsible for the front end piece. The problem that we're creating all of this garbage data and then we're sending it up, that's the API team's problem. That's the backend team's problem. And the backend team, oh, no, 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 it's not our problem that we have to sort through all of this stuff and create all this. That's the data engineering teams. Let's make it their problem. And so and it just ferments and it gets worse and worse and worse down the line. And then someone's left there holding a giant bag. And the problem that should have been, a little bit of planning up front is now a lot of bit of organization and storage problems and all this extra nonsense. And so I honestly, I view a lot of that as a collaboration issue, which is, does this mean that everybody has to attend every meeting? No, but people should be aware of what's going on, right? Treat your teams as they're all part of this organization. We're all part of this a larger team together, and we're aware of what the other teams are doing. We're aware of what the other teams are working on. I can't count the amount of times that suddenly there's some big thing there where we go, oh, team A actually has been working on this massive change to their service and didn't let us know, even though we're a consumer of that. They didn't let us know until the last possible second. And now we have to totally throw our roadmap out of the window to make up for that, right? So I think it's communicating early and often, over communicating, and also communicating through channels that are more global, right? I think a lot of these kind of conversations happen again within the silo of the team, and making sure that those conversations make their way out of that, and that you get that cross team, cross disciplinary flow of information. I think will solve a lot of these problems up front, because again, if I start hearing things that, in 6 months when this is done, I'm going to have to deal with it. Hey, include me in on the next meeting and let's talk.
Yeah, I think the same answer applies to UX and how UX interacts with a good software engineering team. And I'm actually going to kick it to you, Burf, too, but I'm going to throw you a little bit of a curveball that I know you actually enjoy talking about this particular item. Um, both answers, the undercurrent is that collaboration is key, and collaborating with one another is what solves those higher order problems. Collaboration takes care of communication issues, and the tighter the team is, the better they're able to deliver against any needs. And the way that we like to run these cross-functional crews is there should be team members embedded at a specific point. Not to say forever, because that isn't always optimal. But if you're running a Kanban style approach, having people, or not even Kanban, just any good Scrum approach that folks are free to work on specific items where it's not one ticket per human. You could have data engineering and user experience cross-pollinating across product teams, developing and deploying solutions without the need to have any sort of handoff between those crews, because you have one giant pipeline of work that's floating through the machine, and the actors that need to execute on that particular ticket or that particular item are all working together to solve for it. So, Berv, why don't you talk a little bit about that again, specifically collaboration, how we do it, how you've seen it work out, where things have broken down, and how this could apply to, not just data engineering, but other disciplines as well.
Yeah, you and Paul touched on it a little bit, but I worry that some of the verbiage that we use, some people latch on to certain bits of it and kind of take it to an extreme. So I want to repeat something that Paul said and kind of, I mean, Paul, you were 100% right, but I worry that some people here, we need to do some planning up front to save ourselves from issues down the road. That doesn't mean that Ishan comes in and does all the plan on the schema up front and then gives the schema design to a dev team to go implement. That's not what he means when he says that. He means identify that data engineering is needed for this solution. That is the plan, and then get data engineering into the same room as the software engineers so that they can then collaborate on the solution in real time at the same time. So I hope that distinction doesn't get lost in the sauce when we talk about plan a little bit up front, figure out what you need, and then get all the right people in the room to solve that problem together instead of person A solves their half of the problem, gives it off to person B to finish it, because then when person B realizes, oh, we missed something, they don't have to go back to person A or try to solve it themselves. They're collaborating in a room with someone that understands the problem
Yeah.
and they can
And
bounce ideas off of each other.
I have a brief comment to make on that. So a lot of people see these bigger, higher order problems as map reducible, where you hand off each portion of the product problem to an expert that goes into a dark room and solves the problem, and then you reduce, right? That's your map portion of the show. And then your reduce portion of the show is when you come back with all of these little tiny solves and you zip them up into a completed and finished feature. That works great in the machine world, but it doesn't work too good with humans because we're lossy from a configuration perspective. Machines are not. Machines, when they communicate to one another, assuming all packets hit the right place, they have perfect information and they can complete that problem by simply combining all of the particular pieces on whatever criteria you have. When you're looking at a system with humans, there is a ton of questions and a ton of chance of misunderstanding. So the collaboration piece is where you can solve that, and we're a big believer in that. We've seen lots
Yeah,
of teams work really well.
yeah, you see this all the time, and even in other industries like manufacturing. Someone will build the nut and someone will build the bolts, and you get the nuts and bolts together and they just don't work, right? That happens all over the place. So it's
Hmm.
interesting to see how those sort of analogies apply to us as well.
Cool. So we've talked a lot about sort of the how we think about building things. We've talked about where our jobs sort of what the Venn diagram is across that. So let's kind of take this back to the premise of the conversation here, which is how do we think about building versus buying? What's the criteria that now that we have an established worldview on what each organization or each team is able to do, let's talk a little bit more about when we make those decisions. And this is a really hard question, but so take your time in answering it. But let's put the question first to let's go to Paul. When you're looking at things from a business perspective, and let's say that you have a project and you've walked in and you're having a conversation with a CTO, and the CTO says, "Here are my top 5 big issues." How do you identify what might be a build versus buy scenario? Again, a lot of these CTOs are really great at already doing this, but let's just say that you're asked for your advice. What are some criteria that you would lay out that we would look at to decide what we should build versus what we should buy and how we should charter those projects from a business value perspective?
Yeah, great question. And I wish I had a magical. I wish I was as good at doing this as I want to be. I think the biggest thing, like you mentioned, is understanding what the core problems that we're trying to solve are, right? What are the business problems that we're looking to solve? Why are we looking to solve them? Because I think that can color the decision that you want to make. It can extremely color the decision that you want to make, right? So let's say that the core problem is scalability, right? We have some sort of platform, it generates reports, and we have too many reports. We've generated too many, and now when we go to use the report page, it slows down to a crawl and it completely falls apart, right? Then okay, let's make sure that that's ranked on top. Whereas there's other problems where, hey, this is a problem, but maybe it's not actually as big of a deal as you think it is, right? Maybe we think that it's a scalability problem. We say, oh, it just doesn't scale well. Well, let's actually figure out what's going on here. Is the report page just naively loading in every single report that you've ever generated? Okay, well, maybe you don't need to buy a solution for something like that. That's probably something that we can go in and build a specific fix for that, right? We can just add pagination or yeah, right. There's solves there. So I think it's understanding the scale, what the problem actually is, and then the scale and the scope of the problem. And then that allows you to properly prioritize, okay, what are the real big solutions? What are the real big problems that we have? And then I think that to the point of where to build, where to buy, that then allows you to say, okay, is this solvable in our current solution if we build on top of it? Or is this something where our current software just ain't going to cut it? We need to buy something new that handles this specific problem because it's novel. It's not something that we're going to be able to fix just by adding on some additional functionality.
Yeah, I think the big question is going back to the first question we asked is one, what is the motivation to solve this problem with internal humans versus to go and buy a platform that solves this problem for us. And I think a lot of that is you hone in on these giant blocks of functionality, like application lifecycle management software. Nobody's going to build their own. I mean, sure you could, but should you? I don't really know. That's a big question mark, right? What's the diminishing returns, right? If I take in essence, building is buying in a way. You're just buying a pet that you now have to feed and care for, as opposed to if you buy someone else's pet if you lease someone else's pet that they own, that they have to manage and upgrade, then you're getting something out of that. So a lot of the trade-offs that you see CIOs take is, if I buy this particular piece and I stitch it together with a bunch of custom integrations, how reliable can that be, right? Things like Workday, things like there's a million different ERPs out there that maybe we want to take and integrate. And we've even done this internally as well with our own systems, where we notice that, for example, we have a silly Lambda that fills out time for our consultants because I hate filling out time, and we all work 8s every day anyway. So it's like figuring out what's a problem that we can solve with 20 minutes of engineering work versus what's a big problem that is an entire domain that's solved with something that's an expensive piece of software that we buy. I think that's the big challenge that you have to solve for. And to your point, if it's an existing system, adding little pieces to it, you mentioned like the report example. The thing I would think of is, would it make sense for me to go out and buy a Tableau license and spend hundreds of thousands of dollars getting Tableau consultants or my own internal business intelligence team to recreate those dashboards in Tableau? Okay, what did I get out of that? Did I reduce my operational cost, and that now my core engineering team no longer has to babysit dashboards? Or did I simply create a new maintenance problem in another position in the organization, to where now my Tableau and my semantic layer people and my data engineers all have to make sure that these dashboards are up to date? And a big question key to that is, how business critical are these things? So it's a very difficult calculus, right? I'm not not here to say, Paul, tell me all the answers. No, it's a very difficult calculus that every business runs every day. But I think the key differentiator, again, is at what point is building this thing diminishing returns for my organization, taking into account the maintenance and operations cost, which is, again, very hard problem to answer.
Yeah. And just one point I want to emphasize, because I think it's exactly right, is what is the core fundamental problem what is the problem that you're trying to fix? Not necessarily, oh, here's the symptoms. Well, this thing is wrong. This thing is wrong. Well, if we fix those, what value would that bring? And that is the thing that I think you really got to hone in on, because a lot of people, you use software every day. There's going to be stuff wrong with it. Even the best system, there's going to be things that annoy you about it. But if we fixed all of those things, if you buy the perfect system that has all of these bells and whistles and all these features, what are you actually using those features to do? Is it worth the money that you're going to spend buying this new system or building out this whole new system? What are you actually looking to accomplish? What is the end deliverable business goal of this change? And that is like the primary thing that you have to identify before you can make the decision to build or buy. Like, what is it that we're actually trying to accomplish?
For sure. Berv, Ishan, do y'all have any comments on that? Huge, massive question.
Yeah, I like to compare it, being a software engineer, I like to compare it to the build versus source question, right? At what point do you decide that a date picker, I need to go build my own versus use a solution that's already out there, right? To me, it boils down to two big concepts that can then be broken down into like a million, right? What is the cost? Cost could be the monetary cost of actually going and buying it, the complexity of building it or integrating it, the cost that it takes. If I go buy it now, my time to market is faster than if I were to build it. And then, yeah, like you've been saying, Jade, of the maintenance portion of that. Do I have to maintain something long term? Maintaining open source also takes that sort of cost into account as well. So not just cost, but also feature parity. How close to what I want this thing to do does it actually do? What features does it have that I don't need? What features is it missing that I do need? And how close is it without me having to go do that extra work? There's a lot of things that you can add on to that I'm probably thinking of as we speak, but those are the two main topics for me, is the cost and the feature parity. And does this thing
Yeah.
even exist that does what I need it to do?
And I think a big difference between the data engineering world and the software engineering world is that in data engineering, the set of jobs that we have to do are fairly finite, right? You need to move data from point A to point B. You need to aggregate data. You need to turn it into something translatable that the business can use to derive value, right? That's fairly, again, that's a very massive oversimplification of your job, Ishan, but I'll take liberty for that. In the software engineering side, we're asked to reinvent the constant of gravity every day. We're asked to build all kinds of things and build me this magical Lego widget that does XYZ and makes me millions of dollars. So it's a little bit of a different play. So let me change the question for you, Sean. So in your world, what are some obvious things that you just should never build yourself? There are products out there, or there are open source frameworks you should use. Go use them right now.
Yeah, that's actually like a good way to frame it because at least with data engineering, a lot of the way I see it is like, um, for one, like I think a lot of things are really hard to build. Like first, like streaming, right? You're gonna have like
Hmm.
gigabytes, terabytes of data coming in,
Yeah.
and like the opportunity cost of not using something like Kafka or I think Flink
Hmm.
is just really high. And on top of that, like I think what it comes down to is, do you want it managed by like a cloud service, or is there an open source tool that you can maybe build on top of? And yeah, it's
Yeah.
not purely like a build yourself thing, but there's definitely ways to reduce that cost if you were to use an open source tool instead. And just I think you can maybe get it with building something like Infra yourself if you're a very small company, if you have Terraform experts, but it's a very niche thing. Once your business scales up, then you would definitely need to either, find something that's managed by a cloud company or build open source yourself, which would reduce the cost. But that's at least like the way I see it for data engineering when we're deciding what tools to use, just because the amount of data that's
Yeah.
being stored that's arriving, it's really generally not worth especially at like terabytes of data.
Yeah, I have a couple of interesting comments on that too. I think similar on the software engineering side, a good analog is date libraries, right? Anybody's seen the number file, don't ever write your own date code, YouTube, which I send to everyone because it's completely true and it's actually quite hilarious. Similarly, on the data engineering side, I would likely never write my own job scheduler. Why? When I have Airflow. Well, right. Why when I have Delta Lake would I try and manage my own patches in and out of my warehouse. Like, but let me caveat this with the fact that those pieces of software were written by someone. Somebody had to sit
Right.
down and say, you know what, I really think we should do this. And you look at companies like Facebook, which invented React Native. You look at I think Uber or their I forget where Airflow came from. I think it's Apache Foundation. So,
Right.
but there are other really really well-known libraries that came from these giant technology companies that decided, you know what, I think we can do this and we can provide this software as a service to the rest of the world. So I tip my hat to those people because they've produced things that we don't have to do, like mapping and spectral data mapping and all these really cool APIs, so that we don't have to spend hundreds of thousands, if not millions of dollars, and being experts in a specific space to develop and build these tools. So I will caveat this entire discussion with the fact that if you are an expert in your field and you're a multi-million dollar company, or perhaps you're even smaller than that, and you feel like this is the right call if we go and reinvent this particular thing, by all means, go do that. Just understand that if you're Home Depot or you're a retailer, it might not make sense to go and build some some performance computing libraries unless you're trying to do something crazy, which I think is the trade-off. We've discussed this through the entire webinar. Is you need to think through diminishing returns. At what point does it not make sense for us to continue to charge down this path? When using existing software is a better play. So let's wrap this up and talk through closing thoughts. I think we've done a great job of kind of building this out, and the answer is it depends, as usual. The hashtag always consulting answer. But I'm going to give each of you just a quick chance to kind of give us your final perspective on what are some things that you think about when you're talking to customers, and what are some big challenges that you want to make them aware of when we're walking through this decision tree? Many of which we've already touched on, so you feel free to rehash those. But let's start with you, Ishan, and then we'll go to Paul, and we'll finish with Burv.
Yeah, so I think a lot of it does come down to I think the one thing that you mentioned was like data processing, like Spark, or things like streaming or batching. So one, like what is the business end goal? To like if they were to build their own product, would that get in the way of other timelines? And then three, does the cost of using existing, whether open source or larger cloud-based tools, does that put a financial cost on the operations of business? So I think the first thing is to get a minimum viable product in terms of a proper pipeline, which does deal with ingesting data, cleaning it, and schema evolution. And then after that, after something you have an entire work in progress, then focus on potential improvements. Just because unless it's a company that does intend to rival Apache, or it's a large enough company like Meta, which is able to spend time to develop tools like React, it's generally advised to think a little further and focus less on building than buying in terms of data engineering. But I know at the end, it does depend on the business itself, the costs, along with how many experts in that specific field or matter there are to improve the product.
For sure. What about you, Paul?
Yeah, I think Ishan kind of hit the nail on the head, but I will say, yeah, to echo myself from earlier, I think one of the most important things is understand what it is that you're looking to accomplish. So many times when you start talking with people, they talk about, well, we need to buy the Lamborghini, we need to buy the best version of this platform. It needs to have all the bells and whistles. It needs to have 1 million horsepower. It needs to scale to 100 million concurrent users and petabytes of data and all. Well, wait a second, slow down. What is it that you're actually looking to accomplish? What are the business goals that you're trying to accomplish? The reality is you might need a car. Do you need a Lamborghini? You might not even need a car. You might just need a bicycle, right? You might need something much, much, much smaller. And in those cases, building makes a ton more sense than buying an out-of-the-box solution. And again, similar to what Ishan said, also understanding the cost benefit trade-off, right? And I think one thing that I also want to bring up that we haven't mentioned a ton of is also, again, kind of going back to the business value, which is how does this help differentiate your company's value? If this is something that we're just sort of doing in the back end, right? Our ALM or our, it's our SDLC management. Okay, well, these things are relatively in parity with one another. We can change our processes to work around them. But if this is the way that our customers interact with our business, you might want to weigh that build a little bit heavier because you want to have an experience that really differentiates you from the pack. And so I think understanding the value that you're going to get out of the system is really going to help you determine whether or not to build or buy.
Yeah, I like to say, Burv and I were working together on a project, and there was a pitch back to our customer to do this really super fancy, crazy microservices thingamajig. And I remember telling the CEO of the company, "Look, dude, this is a submarine when really all you need is a bass boat. Like, this is a
Yeah.
nuclear submarine, and you just need a bass boat." And I think that in 2026 with AI and vibe coding and people shipping garbage to production every day, like I feel like we're in that position to where now it's not just about shipping a submarine when you need a bass boat, but it's also shipping a bass boat when you don't need a dinghy. That's just out there with holes in it, puttering around on the lake with sharks circling you. So we're kind of in a weird squeeze where good software engineers and good data engineers, it's even more critical to have people that know what they're doing on the ground, which I'm excited about because that's my entire company is built on that. But Burv, why don't you take us home? What do you think? And then we'll wrap this up. And we appreciate everyone's time, and we thanks for listening.
Yeah, I'd like to hammer home the collaboration piece, but the reality is that we don't always get that luxury, right? Software engineers don't always have the luxury of having a data engineer on the team or having a UX designer on the team or things like that. And so a quote that kind of sticks in my head a lot is treat the code that you write as if the next engineer is a thriller serial killer villain who knows where you live, right? And so
Mm-mm.
if you treat the app that you're building like it's going to be used by data engineers and by future engineers to solve problems that maybe the customer hasn't thought of today, that will help make the lives of everybody easier down the road. What I mean by that is don't just take a ticket and say, okay, I'm going to satisfy this ticket and move on with my life. Find out what else that data is going to be used for. Find out what else that screen might be used to analyze or do in the future. Don't go down a 3 week rabbit hole just because you want to, but find out if that system needs to be expanded on in the future.
Yeah, I think the key component here is thinking across boundaries. I've said since I started this company that I want to work in a Venn diagram. I don't want to work in walled gardens. And that statement, that concept continues to apply as we grow, as we get bigger, not just our company, but as the software industry continues to produce incredible amounts of digital assets now at which we can produce at ludicrous speed with AI and agentic and coding AI and all this. I think it's even more important for us to think in terms of we're all here to overlap. We're all here to work with one another. And the best companies do this, right? The best companies that I've worked with, the best companies that I've advised, the best companies that I've worked in, and even us, the way that we think about this is from a seven factor perspective is that we're here to Venn diagram with everyone around us and to solve the problems in front of us, right? No problem is too sacred for us to think about and at least challenge the status quo in an attempt to drive business value and satisfy our customers, but also to satisfy the customers of our customers. And so I think this is a very difficult problem. We picked one of the more hard ones to talk about today that I've seen in my lifetime. I mean, again, you can reduce it to a simple decision tree, and a lot of great CIOs that I know and CTOs that I know do that, and that's totally cool and fair. But from our perspective, the calculus really comes down to the business value you're providing versus the diminishing returns of creating the asset and managing the asset, both from a data engineering perspective and architecture perspective, and from a software engineering perspective and your cloud architecture as well. So thanks for everybody. We're going to wrap up just a teeny bit early today. We appreciate your time, and hopefully you got something meaningful out of this. Big thanks to Burv, Paul, Ishan. Thank you, gentlemen, for joining us. I had a great time talking with y'all, and we will talk to you all later.
Yeah,
Yep,
thanks, y'all.
thanks.
Thanks.